In this part, we will explain the method of preparing a shapefile map for the soil type belonging to the digital soil map of the world DSMW and adding the fields and information to its table with the source of information for each field added to the table, where we bring the file with the title Soil of Iraq and Syria Shapefile UTM, and this file is in the following path as we see. This file is titled Soil of Iraq and Syria Shapefile UTM, where we make for it copy and transfer it to the desktop through paste, and this is the file, and it contains the file titled. This is the file and contains file titled Iraq and Syria DSMW ArcGIS, which contains the shapefile map entitled Iraq and Syria DSMW UTM.SHP for the soil type belonging to digital soil map of the world DSMW, where we open this map in the ArcMap program, where we go to the ArcMap and add the map via add data, and we go to the following path: desktop, Soil of Iraq and Syria Shapefile UTM, Iraq and Syria DSMW ArcGIS, Iraq and Syria DSMW UTM.SHP. Then we press add. The map appears. Then we go to the map layer and the table of content and make right click on it, then open attribute table. The table appears and includes a number of fields that contain various information about this map. We add to this table other fields, where we add field entitled HYDRP by going to the table option, then add field, which is of type text, and in it we place the hydrological soil classes A, B, C, or D. Then we add a field titled KSAT, which is of type float, and we put the values of hydraulic conductivity in it according to the soil type. Then we add a field entitled moisture, which is of type float, and we put in it the values of initial moisture for soil. Then we add a field titled field capacity, which is of type float, and we put in it the field capacity values for the soil. Then we add a field titled wilting PT, and we put in it the wilting point values for the soil. Then we add a field titled texture and put the soil classification in it. As for how to obtain the amount of different soil values in these 6 fields added to the table that depends on soil number of each type, which is located inside the field with the title MUID, where we choose the number in the first line, for example, inside the field titled MUID, and make copy for it via Ctrl+C and go to the following path. We open the file with the title SWAT-US-SSURGO-soils, and then we go and open the file with the title SWAT-US-SSURGO-soils with the MDB extension. Then we open SSURGO-soils, and we make right click on MUID field, then we click on find, then we add the soil number via Ctrl+V, then we click on find next, and we go to the activated line that contains information about this soil, where in the field titled HYDRP the hydrological class for soil is C. As we see. So we go to the ArcMap and add C to the field titled HYDGRP. As for the value of hydraulic conductivity in the field titled KSAT, it must be in centimeter per hour unit, where we return to Sergio-Soils table and go to the field titled SOL-K1 and init the value of hydraulic conductivity for the first layer is 32.4 millimeter per hour. We convert it to centimeter and it becomes 3.24 centimeter per hour, and we add it to the field titled KSAT. And for the initial moisture information about it is often not available, and in this case it is preferable to choose a value for it which is 0.15 as we see here. As for field capacity, its value depends on the type of soil and is present in the following path. As we see, in this file entitled Field Capacity and Permanent Wilting Point.png, where we open this file and in it the values of field capacity FC and wilting point PWP will appear according to the texture. Therefore, we need to know the soil texture and to know the soil texture, we go to the field with the GeoHMS title of the dominant soil for the study area, where we have here on the first line the dominant soil is I, so we go to the following path and we open the file titled generalized-usu-info.xls, and in it we go to the dominant soil I and it contains the percentage of sand, silt and clay. And to find out the classification of these soils, we go to the following path. As we see, and we open the file entitled Soil Classification Program, and in it we open the soil class program for soil classification, where the percentage of sand, clay and silt are required to be entered. where we go to the information table in which the sand ratio for this soil is 58.9. Then we make copy for it via Ctrl C, and we go to the program and we click on clear. Then we add the sand ratio, which is 58.9. Then press tab. Then we go to the information table, and in it we note that the order of values in the first two fields or two columns are for the sand ratio, and the next two fields are for the silt ratio. Then the next two fields are for the clay ratio. Since the clay percentage here is 24.9, we go to the program and enter the clay ratio of 24.9. Then press tab. Then we return to the information table in which the silt ratio is 16.2, and we go to the program 16.2, and we go to the program and enter the silt ratio 16.2. Then we press tab. Then we click on classify. The soil classification is sandy clay loam. We return to the map table in the ArcMap and to the field title texture, in which we enter the soil classification, which is sandy clay loam in the first line. It is also possible to add the values in the field title HYDRP and KSAD, depending on the soil texture from the prepared table. For that, instead of using the table SWAT-US-SSURGO-soil.mdb as in the relation table between texture and field capacity and melting point, where in this table the value of the field capacity FC for this texture, which is sand clay loam, is 27%, i.e. 0.27, and for the wilting point PWP for this texture, which is sandy clay loam, is 17%, i.e. 0.17. Thus, in the same way, we continue entering the information for the rest of lines of the polygons in the table. These 6 fields that we have added to the table titled HYDGRP, KSAT, moisture, field cap, wilting P, PT, and texture are very important in implementing the next series of videos of category GSSHA model in WMS. Note, before entering the values into the field, we go to editor, then start editing, and upon completing the entering information into the field, we go to editor, then stop editing, then yes. This is the shapefile map of soil type for Iraq and Syria belonging to digital soil map of the world DSMW, which 6 fields have been added to it: HYDRP, KSAT, moisture, field cap, working PT, and texture. The spelling for these 6 fields must be as written here without increase or decrease. Where after adding these 6 fields to the map table, we transfer the file on the desktop that contains this map with the title Soil of Iraq and Syria Shapefile UTM to the following path: where the file entitled Soil of Iraq and Syria Shapefile UTM was transferred to this path, and inside it is the file titled Iraq and Syria DSMW ArcGIS, which contains the shapefile map titled Iraq and Syria DSMW UTM.SHP in this path, as we see. Where this map titled Iraq and Syria DSMW UTM.SHP shapefile for the soil type belonging to digital soil map of the world DSMW is the one that will be adopted and used in the implementation of a gridded surface subsurface hydrologic analysis GSSHA in WMS in the next series of videos of the category GSSHA model in WMS.